T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff.
Good afternoon, everyone. My name is Tim Dominic, Chair of the AIAA Public Policy Committee and Master of Ceremonies. Thank you for being with us for the 2021 Durand Lecture for Public Service. We will begin our lecture in just a moment, but first, on behalf of AIAA, let me extend a heartfelt thank you to the Lockheed Martin Corporation, whose incredibly generous sponsorship has made today's event possible. The Durand Lecture for Public Service emphasizes notable achievements by a scientific or technical leader whose contributions have led directly to the understanding and application of the science and technology of aeronautics and astronautics for the betterment of humankind. Dr. William Durand was a United States naval officer and a pioneer in mechanical engineering. During his remarkable 99-year life, Dr. Durand contributed significantly to the development of aircraft propellers, and he was the first civilian chair of the National Advisory Committee for Aeronautics, or NACA, the forerunner of NASA. The Institute's Public Policy Committee takes pride in selecting accomplished leaders in aeronautics and astronautics who can share their knowledge with you through this lecture. To introduce our distinguished lecturer, please welcome a 2021 AIAA Associate Fellow inductee, Robert Lightfoot.
Thank you, Tim. At Lockheed Martin, we're proud of our longstanding partnership with AIAA and their continued mission of bringing together industry, government, and academia in forums like SciTech. Even though we all like to be together during these events, I applaud AIAA for the innovative ways in which they've worked through the pandemic to still provide this great content we've all come to expect. The rich legacy of sharing knowledge and experiences is the hallmark of these events. Lockheed Martin is truly honored to sponsor today's lecture that will no doubt continue that legacy. With that, I'm pleased to introduce my colleague and friend, David W. Thompson, former president and chief executive officer of Orbital ATK Incorporated. Mr. Thompson is the retired president and CEO of Orbital ATK Inc. and a co-founder of one of its predecessors, Orbital Sciences Corporation. He led the company for 36 years, from its establishment in 1982 until its acquisition by Northrop Grumman in 2018. During that time, the company developed and produced more than 1,000 rockets and spacecraft and grew to be a Fortune 500 class enterprise. Mr. Thompson is an honorary fellow of the AIAA and served as its president for the 2009 to 2010 term. He holds degrees in engineering from MIT and Caltech and in business from Harvard. Mr. Thompson will now speak on the history and prospects of commercial space activity. Please join me in welcoming Mr. Thompson.
Hello, everyone. Robert, thank you for the kind introduction and for all that you have done and continue to do for our country's space activities. And Tim, I want to express my gratitude to you and the AIAA Public Policy Committee for selecting me for this important award. Tim, as you pointed out, William Durand was a leading authority in aeronautics in the first half of the 20th century. He served as the first permanent chair of NACA and established one of the first university-level aerospace engineering departments in our country. Sometimes we think the rate of technological change in our times has been exceptionally fast, but the life experiences of Dr. Durand keeps things in a proper historical perspective. He was born a couple of years before the outbreak of the Civil War, and yet lived to see the first artificial satellites launched into orbit. This AIAA Public Policy Lecture Series is a fitting way to honor this remarkable man. My subject today is the history and prospects of space commerce. I was fortunate to be at the right place, that is, in the United States, and at the right time as I began my career in the late 1970s, to observe and to participate in many of the extraordinary developments that propelled commercial space activities during the last 40 years. So from that background, what I'll try to do today is to give you my perspective on three questions related to space commerce. First, what is it? That is to say, what do we usually mean by this term? What type of economic activity is involved, and what is its current size and shape? Second, where did this industry come from? How did it develop, and who were some of the most important pioneers that brought it to life? And third, what's ahead in this area over the next 5 or 10 years? So if we go to my first chart, to begin with this first question, here's my general purpose definition of space commerce. An economic activity which involves space-related systems, products, and services characterized by three features. First, their development and production by private sector enterprises. Second, their financing with a substantial degree of private risk capital. And finally, their marketing and sale to a broad group of customers, including companies, government agencies, and where applicable, consumers. Now, some space activities clearly satisfy all three of these criteria. The development and manufacturing of commercial communication satellites, the operation and use of such spacecraft to provide various types of communication services to many different classes of customers, and the design and distribution of ground receiving equipment and user access devices all fit this model, and as we'll see, represent collectively the largest example of space commerce to date. There are other pretty clear-cut cases that fall into this broad category. These include the development and manufacturing of GPS and other satellite navigation devices that are used in consumer and industrial applications, as well as the production and operation of privately owned imaging satellites. Still, there are many critical space projects that are not inherently commercial and do not meet one or more of these criteria. Strategic communications and warning satellites for the military, imaging and signals collection space systems for intelligence agencies, space missions intended to explore the solar system for NASA are examples of inherently non-commercial space activities. And of course, as in any categorization, there are some activities that are less clear, where the boundaries are continuing to shift, such as in the privatization of space systems originally developed for government-only use. Perhaps we can discuss some of these gray zone cases in the Q&A period at the conclusion of my talk. The graph in the lower part of this chart is a highly approximate representation of annual revenues generated across the commercial space sector over the past 5 decades. We'll get into some of the more quantitative measures of commercial space activity in a few minutes. Here, I'd only like to convey that the first 50 years of space commerce looks a lot like the life cycle curves that one finds in many other industries. Early pioneering adventures and foundational applications lead to intervals of rapid growth and geographic expansion, and eventually to periods of transition where uncertainty exists about the future that may be characterized by renewed growth, relative maturity, or even decline. Today, I believe, and for the next couple of years, we will continue to be at the first of these transitional periods for commercial space activity. If we move to the next page, before we look back at the markets, the products, and the companies and their leaders that created much of today's commercial space industry, I'd like to talk a bit about its current size and shape. Here are some estimates from a number of groups that track space activity about the overall size of both commercial and government space spending. This data is from 2019, the latest year for which comprehensive information has been published. And while the individual estimates do vary from one source to another, a common theme that they each focus on is that now substantially larger amounts of annual investment are being made in commercial space activities compared to government spending. In fact, on a global scale, typically the ratio is about 3 to 1, perhaps even a little larger in favor of commercial activity. Now, in my view, it is likely that all three of these sets of estimates probably overstate the true economic value of space, of commercial space activities, possibly by some considerable factors for a variety of reasons. But I will use in our discussion the first of these provided by the Satellite Industry Association in collaboration with Bryce Space and Technology, because I believe their work is the most consistent and it covers the longest duration, looking back over the development of our of this sector. If we go to the next page, here we look a little bit closer at what makes up commercial space activity today. As this chart illustrates, there are three broad segments of space commerce: satellite delivered services, satellite ground equipment, and space infrastructure. The first of these, satellite services, represents customer spending of about $123 billion in 2019, which was about 45% of total commercial space industry revenues of some $271 billion. The second, ground equipment and customer access devices, generated about $130 billion in revenue, amounting to approximately 48% of the industry's total. And the third segment, involving the development and manufacturing of satellites and rockets and other elements of space infrastructure, contributed the final 7% of industry revenues. Now, for me, and probably for many of you, the reality that space infrastructure is such a small part of the commercial space economic activity comes as a bit of a surprise. It's a bit like learning that ordinary matter makes up only 5% of the matter energy density of the universe. Nevertheless, being made up of ordinary matter myself, I still think this is important, and I think you'll probably agree with me. While you take this in, I would also call your attention to two factors or two contributors to the green and purple pie charts here. In the case of satellite, TV, and radio broadcasting on the left side, and GPS devices and equipment on the right side. Together, these two business areas make up about 70% of total space commerce revenues. Again, in 2019, according to Bryce Space and Technology, they accounted for about $195 billion in economic activity. And together, were more than 10 times larger than satellite and launch vehicle manufacturing. Some of the recent trends and perhaps the near-term prospects for these two applications will have a dominant influence on the near-term outlook for commercial space activity as we enter the new decade. Now I'd like to address the second question, which I'll do with the next series of charts. And that is, where did this very large industry come from? If we go to the next page, I'd like to give you a highly compressed 10-minute history of space commerce in the form of 10 pioneers that brought to life many of the foundational businesses that have created this industry sector. Each of these pioneers deserve a much longer and more detailed discussion than we have time for today. Fortunately, the AIAA Space Commerce Lectureship, which was inaugurated in 2018, will, I believe, capture and document the stories of these trailblazing leaders and the foundational applications they brought to life, and preserve those records for the future. But let's start by going back about 5 decades, maybe even a little farther, to the point just after the Big Bang event in the commercial space universe, namely the advent of commercial communication satellite services. The two individuals at the top of this chart, Joe Charick, Harold Rosen, I think can properly be considered as the fathers of space commerce. Joe was the first president of the Communication Satellite Corporation, or ComSat, when it was established in 1963, and he served in that capacity through the mid-1980s. During his tenure, he saw the development of the first global satellite communications network that, by the time of his retirement, 1985, reached about 150 countries throughout the world. His partner, Harold Rosen at Hughes Aircraft at the time, really invented the geosynchronous communication satellite. He and his team led the design and production work that resulted in the early bird satellite that was launched in 1965 for ComSat, and for the development of several subsequent generations of commercial communication satellites. During that same early period, several other trailblazers deserve important recognition. Frederick Deleste, commercial launch pioneer at Arianespace, and Charlie Trimble, GPS applications visionary, are my two favorites. In Frederick's case, he was the founding president of Arianespace, the first commercial launch operator, and he served in that role for a decade. That led to the position by the early 1990s with Arianespace as the leading commercial launch vehicle operator. And in Charlie's case, as the founder and longtime president of Trimble Navigation, his foresight relating to non-military applications of the GPS network was truly extraordinary. And Charlie, more than I think any other single individual, is responsible for the terrific proliferation of GPS and other satellite navigation enabled devices that today number almost 7 billion units in service around the globe. If we move up to the next page, we'll see how their early work led to a period in the 1990s and 2000s of rapid growth and international expansion of commercial space activity. Eddie Hartenstein, the pioneer of direct-to-consumer satellite services, and Ramon Bausch, the leading European satellite architect, are the two outstanding contributors that come to mind during the early part of the 1990s. In Eddie's case, he founded DirecTV in 1990 and led for the next 15 years its growth to become the largest space-based business of all time, reaching revenues of some $30 billion a year in 2015 when it was acquired by AT&T. In Ramon's case, he founded SES Global in 1985 and served as its president for about 30 years, during which time SES emerged as the world's largest operator of commercial geosynchronous communication satellites. Their work was complemented by that of a variety of ground system companies led by the inventor of VSATs, or very small aperture terminals, Pradman Kaul, who at the time was at Hughes Network System, which was subsequently EchoStar HNS. Pradman invented the VSAT technology that has now expanded to some 15 million installations around the world during the 2000s and 2010 decades. And finally, Walter Scott, the original entrepreneur that more than anyone else created the commercial satellite imaging industry, founded Digital Globe in 1993 and continues today as its chief technical officer, with Digital Globe being the largest operator of commercial imaging satellites in the world. On the next page, we see, of course, that history did not stop a decade or so ago, and there's still quite a bit of progress that's been achieved in recent years. I would here point out two additional pioneers, Mark Dankberg, satellite industry trailblazer, and Gwen Shotwell, a reusable launch vehicle innovator and commercial cargo and crew transportation leader. In Mark's case, he founded and for over 30 years led Viasat as its president. Viasat became the first operator of satellite internet services almost a decade ago and has continued to innovate with very high throughput geosynchronous satellite technology over the past decade. And in Gwen's case, she led the team at SpaceX to achievements in recent years as the first operator to provide commercial delivery of cargo to the International Space Station. And then just this past year, the successful advent of commercial astronaut transportation to low Earth orbit, while at the same time inspiring a new generation of space entrepreneurs. Looking ahead to the decade of the 2020s, I'm certain there will be new pioneers that enter this Hall of Fame. They may take the form of those working with small satellite applications in distributed networks, or perhaps in the use of in-space robotics and other autonomous operations, or in many other areas yet to be fully developed. If we go to the next page, finally, I'd like to turn our attention to the third question, which concerns the future of space commerce. To do this, I will in part rely on the experience of recent years to provide a bit of a guide to the near-term future. And I'll begin by once again using the Satellite Industry Association's database, starting with a look at commercial space revenue growth over the past 20 years, which is depicted on this chart. As it indicates, commercial space revenues increased during the first decade of this century, 2000 to 2009, at a relatively robust rate of almost 11% per year. This was driven by continued growth in satellite services and consumer navigation equipment, both standalone and embedded devices. However, the data for the past decade, 2010 to 2019, tells a somewhat different story. During the past decade, average annual growth dropped to just over 3% per year, with all three segments, satellite services, ground equipment, and space infrastructure, all declining substantially compared to their growth rates in the prior 10-year period. This means that while space commerce revenue increased 150% over the first decade, the revenues grew by only about 30% over the second one. Next, the next page gives us a chance to take another look at recent developments in commercial space activity. This plots the year-by-year magnitude of financing activity for commercial space enterprises over that same 20-year period that we saw on the previous chart. This data, which is also drawn from Bryce Space and Technology, shows average annual investments in new space businesses that averaged about $460 million per year during the first decade of the new century, and which increased about fivefold to nearly $2.4 billion per year in the period 2010 to 2019. The half-decade averages that are shown at the bottom of the page also reflect substantial period-to-period increases. In total, through 2019, some $28 billion was invested in space startups. And if we add in the not yet final numbers from last year, I suspect that total will approach the mid $30 billion range. So if we go to the next page, my final graph, here I display the data from the last two charts on the same plot. So what does this tell us? Well, to me, it warns of some trouble ahead. Market growth falling by 3.5 times, as illustrated by the green curve, and annual investment increasing by over 5 times, as shown with the blue curve. Reminds me of the old 1960s era television program Lost in Space, and in particular, the frequently heard warning, danger, Will Robinson. So, to conclude, the next and final page, the future of space commerce is bright, is dim, or is uncertain. Of course, we need, in any industry that is dynamic and any market that is efficient, we need both the bulls and the bears, the optimist some of whom are quoted here in green, the pessimist, cited in red, and many others that are somewhere in the middle. For the near term, say the next 3 to 5 years, I am quite cautious. I think the commercial space sector is likely to be caught in the downdrafts of shifting consumer preferences for TV and other media access, and for a while, stagnating demand for embedded satellite navigation and timing capability in a variety of smartphones and other mobile devices, while at the same time perhaps being buffeted by the cooling off of the currently overheated risk capital markets. But I'm fundamentally an optimist over the long term, and so looking out 10 years or more, I think it's likely that new applications, new technologies, new economics will reinvigorate space commerce, and over the long term, it will serve to the benefit of the people, the enterprises, and the countries on Earth. Thank you all for listening today, and I'll now hand things back over to Robert and Tim.
Well, thank you, Dave, for such a fitting tribute to William Durand. Having worked for you at Orbital ATK, it's rather fascinating to me to see how the space commerce market has evolved over the decades, and really excited to have been able to participate in its expansion through Orbital Sciences and Orbital ATK. But now for the award presentation. On behalf of AIAA and Lockheed Martin Corporation, it is my privilege to present to you with the Durand certificate and medal. So if you would please hold those up for everyone to see. Congratulations on the award and wonderful lecture. Now we'll start taking questions through the chat. So if anyone in the audience has a question, please enter it in the chat box below. To get things started, do have an initial question to seed the discussion. Goes back to about 30 years ago. Dr. James Stewart lamented the fact that there was a lack of a killer app for space that would help drive the small satellite marketplace in the way that Lotus 123 and WordPerfect got us off of mainframe PCs and onto PCs. When you take a look at past visions for commercial global cell phone and internet networks, and as well as fixed and mobile satellite services, a lot of those technologies have been overcome by the economics and innovations of terrestrial companies. We are making a lot of great strides in finally bringing true utility to small spacecraft, and launch costs are getting a lot lower. But is there a killer app yet, and what might that be for commercial space?
Yeah, thanks, Tim. It's a very insightful and thought-provoking question. I think there are, as you alluded to, some important positive trends that are at work today that may help us discover the next really big set of applications for commercial space systems. But those are also occurring in the presence of some significant near-term negatives. And on the positive side, we see satellite cost per unit of capacity continuing to fall at quite dramatic rates. This is a phenomenon that has been at work for at least 40 years. And if anything, it's accelerated in recent times with the advent of both high throughput geostationary satellites and lower cost low and medium altitude satellites. Second, we've also seen significant reductions in launch prices per unit of payload across a fairly broad spectrum of payload classes. And finally, at least in recent years, and for the immediate term, a substantial reduction in the cost of investment capital. So these have all worked in a positive way in the past 5 years. On the negative side, as I mentioned earlier, we are currently experiencing declining or at least maturing demand for what have been the two real killer applications of commercial space technology in the past couple of decades, namely direct-to-consumer television and radio broadcasting from satellites, traditionally from geostationary satellites, and both the application of satellite-based navigation and timing in standalone products, as well as embedded in a variety of smartphones and similar devices. We also are dealing in the short term with delays in market growth in a number of areas that had been previously anticipated to be early adopters of a new generation of broadband satellite delivery systems, including those in mobile applications such as in in-flight connectivity and in maritime communications. These two market areas in particular, of course, have been very seriously set back by the pandemic, and it may take several more years for them to recover and to generate additional demand for satellite systems. So the questions then remain, will actual market demand in the face of some of these headwinds, as well as existing space and terrestrial competitors and substitutes, live up to the expectations of investors and new companies? Will potentially uncertain outlook for major U.S. government programs and funding also become a bit of a headwind? And what might happen should the current favorable view of space investments by the providers of risk capital turn down as a result of some near-term setbacks?
That's a very, very great amount of insight into where we see the market going. Some other questions coming from the chat. When you talked about not knowing which direction the space commerce market was going to go, the renewal portion of your curve on one of your earlier charts, what technologies do you think might be driving that phase in space commerce, or have the potential to drive that phase in space commerce?
I have often thought about commercial space activities falling into two very broad categories. One category involving economic value being generated by by systems that once in place essentially process photons, and the other category relating to systems once in place deriving value from the transportation of matter. So it's sort of a wave versus particle duality. And I tend to be more optimistic, at least as we look out over, say, the next decade, about businesses that are essentially those that are involved in collecting, processing, and transmitting photons than I do about businesses that are going to be involved in the acquisition, the transportation, and the processing of matter. So by that I mean I'm not particularly optimistic about space tourism. or about space manufacturing of materials or products in space. I tend to be more interested in systems that collect information from space or that transmit communications content using space systems. So I know that's a fairly general answer to the question, but that's been my thinking for a long time, and I believe it's still appropriate for at least the near-term outlook in commercial space activities.
Okay, so if we look at the other side of things, then opposite the renewal phase, do you think the market might be saturated, and that's what's driving some of the more shaky projections for the space commerce?
Well, I think in regard to what has been the single largest commercial space market area over the past, say, 25 years, again, direct delivery of television and radio to consumers from satellites. The real difficulty there, particularly on the television side, is the same one that is affecting pay TV, cable TV in the US and to a lesser degree in other developed economies around the world. And that has to do with changing consumer behavior for the way television and related program is being consumed, moving from a broadcast model where everyone watches the same programming at the same time to more of a unicast or streaming model where you watch your favorite program when you want to, and I watch my preferred program when I want to. So the cord cutting, what's been called the cord cutting changes in that market have really been very tough on satellite TV broadcasters beginning several years ago. The final number, I haven't seen the final numbers for 2020, but I suspect if we look at the two largest satellite TV providers in the United States, namely DirecTV, again, part of AT&T, and the Dish Network affiliated with EchoStar, there'd be several million customers that have dropped those services in the past year. And so even though prices have inched up a bit, which have helped to cushion the reduction in revenue in those areas has fallen. And when you've got an area that even just a couple of years ago is representing $100 billion in annual revenue, when that market sneezes, the whole sector gets pneumonia. And so that's I think been the fundamental driver. In addition, for a variety of reasons, including some saturation effects with smartphones for a number of reasons, unrelated to space technology. The number of new smartphones being sold on a global basis has declined from what had been a very fast growth rate for 15 years or longer to a static or even a slightly declining rate in recent quarters. So those two areas, which, as I mentioned earlier, have in the last few years represented about 70% of total commercial space revenue, are not healthy at the present time, and it'll take a number of years before areas of growth can be large enough to offset that downturn. I think probably the areas that have at least a chance of doing that are broadband satellite systems, both traditional geostationary satellites as well as low and medium orbit constellations, and possibly imaging satellites, but those are both starting from very small revenue levels compared to those two very large applications I alluded to earlier. To give you a sense of that, commercial imaging satellites, very, very impressive what has been done there, but from a business standpoint, revenues from those systems are still pretty modest, on the order of a couple of $1 billion a year, compared to, again, $100 billion or so from satellite TV and radio broadcasting.
So you mentioned the cord cutting phenomenon is sort of a negative market disruption. Are we still seeing the effects of other market disruption areas, such as in a positive way, such as the successes in private space launches and other activities in commercial space? Or are we more in a more settled environment where we've kind of shaken out what some of those disruptors are? We now have a new set of players in all those areas.
I think we're pretty far along in that part of the transition. Some of the incumbent spacecraft manufacturers and launch providers are successfully navigating that transition. Some new entrants have entered those markets with in varying degrees of success. But those areas, I think, although they're near and dear to the hearts of many of us as AIAA members and space technology professionals, those really are the tail on the much larger dogs of satellite services and ground equipment, user access devices, and so on. They may enable new services, and with those new types of user equipment, but those new services have to stand the competitive test compared to both existing space-based services as well as terrestrial alternatives, and that's always been true in satellite communications, and the boundaries have shifted over time. For instance, away from telephony through satellites, which had been an early application, and now more recently towards video, and that's fading. So perhaps broadband will pick up some of that slack. But just as in the case of satellite imaging, satellite broadband is still a fairly small and embryonic market area. A couple $1 billion a year is the best estimate from some of the sources I cited earlier for the size of satellite broadband, yet tremendous amounts of capital are going into that area. I suspect not all of the satellite broadband systems that have been discussed will actually be built, but if they were, or if the top 5 non-geostationary broadband systems were developed, they represent a capital investment of something in the range of $20 billion for a market area today that's generating maybe 1/10 that in revenue. So to have that investment generate a compelling return on investment to allow subsequent generations of those systems to be built will require very dramatic growth in revenue over the next 5 years. And that may be possible. I think that'll be a very interesting area to watch. to see how it comes out.
Oh, thanks for that. So a lot of the discussion we've had today has really focused around low Earth orbit and geostationary orbit for the space commerce market. If we take a look at deep space, do you expect space commerce to attract private companies and investment for maybe astrophysical research or other types of deep space projects that, or do you think they'll have financial hardships due to the fact that money's being kept inside the orbits closer to Earth?
There may be a few exceptions to this, but in general, I do not think that most of the concepts for commercial deep space applications will be financed, or if financed, will be commercially successful. That may change over time, but if we take say a 5 to 10 year time horizon for assessing the viability of those types of ventures, I think that the outlook is relatively poor. Of course, for many years, people have thought about and speculated on areas such as lunar or asteroid mining, large-scale energy production in space, and so on. I would never want to say those will never come about, but I don't think there's a really serious financial case for those sorts of things today. Again, who knows, 10, 20 years from now, a lot could change, but
Right.
But at least my experience has been it's pretty tough to in our business, it's pretty tough to plan for more than about a 5-year time horizon. Anything that goes beyond 10 years gets to be very speculative.
Okay. Well, we have time for one more question. And now putting a policy spin on the discussion, what are the government policy recommendations that you think could be made to help facilitate growth and revenue opportunities within the space commerce market?
I've seen the evolution of government policy in the United States now for over 40 years as it relates to encouraging commercial space ventures. I think, although there have been some missteps along the way, I think the general direction of those of how public policy has evolved has been favorable. I think many of the obstacles and impediments that existed back in the 70s and 80s have been removed. There are, I think, at any time, probably, it's true today, there are always a few areas that need attention. I'm a couple of years out of date in terms of details, so I won't try to cite any specific ones, but I would say that the general direction of public policy has been quite favorable, and that's been true largely independent of political parties or administrations and so on. Some have been a little more enthusiastic than others, but I think now spanning 7 or 8 administrations and 2 or 3 times as many Congresses, at the federal level, public policy has been increasingly favorable. And the same, to some degree, is true at the state level. It's, I think, much less important there, but there are some cases where states have facilitated in public-private partnerships and watch sites and things like that, the development of new commercial space capabilities. So I'm not knowledgeable enough today to cite any specific examples of where improvement might be necessary, but I do think that if I compare today to where things stood when I was getting started about 40 years ago, that things have really moved quite a long way in a good direction.
Well, Dave, thank you very much for your lecture today, and thank you for entertaining the audience's questions and my questions as well. I think there's a lot of lessons to be learned through the history of the commercial space market, and certainly there's a lot ahead for the market as well. For the audience, that concludes today's program. We hope you've enjoyed it. This program has been sponsored by Lockheed Martin, and we want to thank them again for their generous support of this lecture. It's greatly appreciated. As by doing so, they continue their long and storied tradition of supporting the kinds of discussions that will drive our industry forward in our quest to evolve technology and better understand the universe we inhabit. Before we depart, though, as chair of the Public Policy Committee, I would like to end this session with a short video. It's an interview with the AIAA's president-elect candidates. I hope you will turn out and vote between January 27 and February 19th at AIAA.org/vote. Again, thank you to all of you for joining us, and enjoy the next 2 weeks of the AIAA SciTech Forum.
So what do you think the role is going to be for the next president at this moment in time, and why are you the right person for that role?
AIAA has always had a reputation for technical excellence. But going forward, if we want to be successful at shaping the future of aerospace, we'll need to be more innovative in our approaches, more agile in our decision-making, more collaborative in our programs, and more responsive to the needs of our members and to changes in the world around us. My top priority as president will be to strengthen our membership recruitment focus, especially for students and young professionals. I'm confident that by working together, we can make AIAA the organization of choice for aerospace professionals everywhere.
Well, I look at all that as an opportunity for the Institute. Our membership, I think, thrives on innovation. We're all in this industry because we love being at the leading edge of capability and performance for the systems that we work on. So I think that does translate to the Institute and what we're able to do and leverage what we've all learned about this new environment that we're in. And so to your point, it's kind of an inflection point for us to go kind of take all that and really use it to evolve and invigorate our membership and our capabilities as an institute to really continue to advance the industry as a whole and the working professionals who support it.